In the name of Almighty God, the most compassionate and the most merciful, I welcome you all, my dear friends, to your lovely channel. Please find a place. Today we will have our general information or introduction on trigonometry. Basically, inshallah, by the grace of Almighty God, we will have our lectures on trigonometry from the basic up to high level, I mean up to advanced level. The students who are getting prepared for the NEET, for the NCRT, for the JEE, for the mains or other boards, whatever, you will have inshallah the complete lectures on trigonometry with the best example. And by the grace of Almighty God, I will have every week one or two lectures on trigonometry. By the way, before starting the introduction on trigonometry, we have a philosopher of the German whose name is Johann Friedrich, I think. Yeah, Johann Friedrich Herbert. He says that there is a section in mathematics which occupies the mathematics, approximately half of the mathematics, and that section is trigonometry. Indeed, in every aspect of the mathematics, maybe that would be functions, that would be limits, that would be derivatives, or it would be integrals or integration, whatever. You might have more than 50% which covers the question that is the usage of the mathematics, maybe the formulas or maybe the laws or whatever is. By the way, in early class, I mean maybe in 7th class or 8th class or 9th class, you have studied the triangles. In triangles, we have one situation that is right triangle. Right triangle. I mean like this one. One of its angle is 90 degrees. Am I right or not? Or one side is perpendicular to the other side. If one of the angles is 90 or it is a right triangle, on that occasion two angles are acute. Two angles are acute, I mean less than 90. Maybe this one is 30, this one is 60, maybe this one is 40, maybe this one is 50. By the way, two angles are acute and one angle is right angle. Now, the usage of the right angle, you know in your nature. For example, a very simple example, if I say what is the usage of the triangle of the right angle triangles. For example, we have a temple here. Now, you don't know what height it has, but you are here and you know the position of yourself with the temple. The position is X meter, and you can watch the height of the triangles with a degree. That is maybe 30 degree, 40 degree, whatever is. Now, by usage of this angle and this distance, you are able to find the width, the height of the triangle. So, this triangle which makes here in nature, this is a right angle triangle. Inshallah, in trigonometry, by usage of the relations of the sides of the triangle with the degrees or with the angles, you might be able to find what side you want. Or for example, another example I can say. For example, we have here a building. This is a building which we have here. There is someone who is walking here, and there is someone who is walking here. Both of them are coming toward the buildings. I don't know which distance does it have from this building, maybe y meter, and I don't know which distance does this person have from this building. Maybe this one is x meter, but we have this one, the degree that this person can watch the top of the building, and also we have this one. Now, or maybe we might have the what? Maybe we might have the height of the building. Now, what is the total distance with A and B? You are able to find in trigonometry. Or for example, another example we can say. For example, we have a building here. We have a building here. Am I right or not? Yes. There is a balcony. Now in this one, a girl is standing, or maybe a smile by, or maybe a teenager, whatever. Now we have a river here. We have a river, and in the bank of the river we have here maybe a masjid or a church, whatever. For example, we have here a masjid, and there is a pot in which a flower is planted. Now this girl is watching this pot. Now I ask what the width of the river is. You are able to find in trigonometry, inshallah. Or for example, another example we can have. Suppose this is a ground next to the sea. We have in here a balloon gas, maybe a hot balloon gas, for example like this one. Now a girl is watching this balloon in point A. She doesn't know what this one is. It's the first time of her that she has watched this balloon gas. Now suddenly she runs to her house in order to has his mother with her. When she goes to house and she takes the hands of her mother and says, there is something in the air. Now her mother is coming. This one is her mother. In this occasion, the balloon is not in A point. The balloon might be in B point, in here. Now there is another angle. Now I want to ask what this height is. What this height is, you have to find. Or what this altitude is. In the first occasion, it was in point A. In the second occasion, it is in point B. Now you have to find. There is a change in the degree. The first was maybe 60. And the second degree is less than 60, maybe 45, maybe 30, maybe whatever is. Now, in this section, in this beautiful chapter, which is trigonometry, you are able to find such questions. I think you have got. By the way, the word trigonometry it is taken from three words. First is tri, which means three. Second, gonia, which means angle. And metron, which means measurement. Trigonometry is taken from three words: tri, gonia, and metron. The complex form of these three things, it makes the what? The trigonometry. Trigonometry, and early before, we used trigonometry, and early before, we used trigonometry in Egypt and Babylon. The philosopher before, early before, they used to find the distance of the stars or maybe planets from the earth. By usage of a triangle. Right now also, even today, the most complicated technology, maybe in engineering or maybe in physical world, it is based on the trigonometry concepts. You will have inshallah all information when you watch the complete lectures on trigonometry. And early before, we used, in Egypt and Babylon's philosopher, they used to find the distances between the stars and planets from the earth by usage of the triangles. And today also, we have the usage of the trigonometry in most complicated technologies. By the way, in trigonometry, you will have, inshallah, the relation between what? Between sides of a triangle and the angles of a triangle. For example, we have this triangle. It is a right angle triangle. Now this side is A, this is B, this is C. What are the relation between B and C, B and A and B, or C, or maybe B with this one, or maybe the degrees or the angles? The all relation between the sides of a triangle is studied in trigonometry. One thing I have to say, that we restrict our information for the acute angles. We will restrict our information and relation for the what? For the acute angle. After some lectures, we are able to find the relations of the what? Of the side of a triangle, even the angle is not acute. If this one is 90, if this one is more than 90, 120, 150, 180, whatever is. But they are, or we can find those angles and the relations of the side by usage of the acute triangle. If I am able to find in a right angle triangle the relations of the side, by usage of this one we are able to find if this angle is 90 or maybe 0 or maybe more than 90. Now how? Write it please. Trigonometry ratios. I have to introduce which ratios we have to use in trigonometry. First, in a right triangle, this degree is, or this angle is, I think, 90, and this one is an acute angle. Am I right or not? Yes. If we have the name, it's A, B, C. The side before the A angle, it is A, this is C. The side before this one, it is B, for example, and this one is C. Now, in a triangle, if you want to find the ratios or define the ratios, first you have to locate in an acute angle. Now, this is our acute angle. You have to locate here. Or this is an acute angle, so you have to locate yourself here. But you are not able to accrue yourself or to place in B. Why? The angle is not an acute angle. First, if you want to define the ratios in a trigonometry, in a triangle, first the condition is, what are the conditions? The conditions, first one is, the triangle must be what? Right angle. Right angle triangle. If it is not a right angle triangle, then you are not able to define the trigonometric ratios. Yes. Second, you have to place yourself in an acute angle. These are the conditions. Now, if you do these two options, so your angle is alpha. It means you are located here. The side before yourself, before the angle A, or the side with respect of the A angle or alpha angle we are talking, this is called opposite. This one is called opposite. This is called adjacent. What is adjacent? Adjacent is the side which is with the alpha or acute angle, and the side before the 90 degree, this one is called hypotenuse. Hypotenuse. The side before the what? Before the right angle. That's called hypotenuse. I think you have got. For example, if I say this is a triangle, which triangle is this one? This is a right angle triangle. It should be right angle triangle. Else we are not able to define our trigonometric function. So if I have the names M, N, P, now this is beta. Now what is adjacent, what is hypotenuse, and what is the opposite side? First, the condition is right angle triangle. Yes, it's right angle triangle. Second, you have to place yourself in an acute angle, which is shown here, beta. Now the side before the 90, first you have to define the what? Hypotenuse. Now the side before the 90 degree, it's called hypotenuse. This is hypotenuse. The side before the degree which is shown, it is called opposite. And the remaining side, it's called adjacent. For example, another example we can have. Now, it is not a right angle, or now it's right angle. Am I right or not? This is called gamma, x, y, z, p, n. Now, what is opposite, adjacent, and hypotenuse sides with the respect of the gamma angle? First, you have to check, is it a right angle triangle? Yes, this part is a right angle triangle. Second, you have to place yourself in an acute angle, which is shown here. Now, for the gamma, what is hypotenuse? Hypotenuse is located in front of the what? The 90 degree. This is your 90 degree or perpendicular side. This is called hypotenuse. Now, what is opposite with the gamma? What thing is in front, it's called opposite. And the remaining is this part. This one is called adjacent. I think you have got. You have complete information on what is adjacent, what is opposite, and what is hypotenuse. Now, with respect of defining of these sides, now you are able to define the trigonometric ratios. Write it please. I will define. Okay, now this is our right angle triangle. Alpha is an acute angle. This is our opposite side. This is our hypotenuse, and this is our adjacent, this side. Now you're able to define the trigonometric ratios. First, we have sine of which angle? Alpha, not this one. Why? If we define this angle, so this side is our what? Our opposite, and this is adjacent. Now, with the respect of alpha, we have to define the trigonometric ratios. Sine alpha is what? Sine alpha is, the definition is opposite divided by hypotenuse. What sine means, what is the origin word of the sine, we will talk inshallah later. Now in here, sine is opposite side by hypotenuse. What's opposite side? It's A. What is your hypotenuse? B. A by B. A divided by B. This is called sine. cosine. Cosine, it is adjacent by hypotenuse. What is adjacent? C. What is hypotenuse? B. We have another tangent, which we can write TAN, tangent. Tangent. It is opposite divided by adjacent. Now, what is your opposite? A. What's your adjacent? C. A by C. The remaining, which is cotangent of alpha, it's adjacent by opposite. Now, what's your adjacent? C, opposite A. C by A. The next one is secant, or sec, we can say. Sec alpha. It is hypotenuse by adjacent. Hypotenuse by adjacent. What's your hypotenuse? B, and adjacent C. B by C. And the last one is cosec or cosecant alpha. It is hypotenuse by opposite. Hypotenuse by opposite. What's your hypotenuse? B. What's your opposite? A. If you put a mirror here, now look, tangent with cotangent. Tangent is A by C, cotangent is C by A. It means they are reciprocal of each other. This one is also cosine with sec. It's C by B, this is B divided by C. They are reciprocal of each other. And the last one, sine with cosec. It's A by B, and this one is B by A. It means cotangent, secant, cosecant. Cotangent, sec, cosec. They are the reciprocal of the tangent, cosine, and sine respectively. How we can write this one in mathematics? We say sine of alpha is equal 1 divided by cosec of alpha. Sine is not equal with cosec, but it is equal with the reciprocal of the cosec. Now, if you use cross multiplication, it is sine alpha times cosec alpha is equal to 1. This is your first equation. Also, cos alpha is equal with the sec, or cosine of alpha is equal 1 divided by sec alpha, or we can say cosine alpha times sec alpha is equal to 1. And also tangent with cotangent. Tangent alpha is equal to 1 divided by cotangent alpha, or by usage of cross multiplication, you have tangent alpha cotangent alpha is equal to 1. If I make a question here, what is sine 22.5 times cosec of 22.5? Now, what would be the result? Now you can see that this one is alpha, this is also the same alpha, and they are reciprocal of each other. From this equation we can say the result is 1. If I ask you tangent 0 times cotangent 0, it's 1. But tangent 0, cotangent something else, not 0, on that occasion, it's not 1. Am I right? For example, cosine of 12, secant of 12. Cosine of 50, secant of 50. Cosine of 10, secant of 10. Whatever other angle you are taking, the multiplication would not be 1. But if these alpha are same, on that occasion the multiplication must be 1. I think you have got. In trigonometry, we use more sine, cosine, tangent. These three ratios. And we do not use cotangent, sec with cosec. Why? Because they are reciprocal for the first three. And mostly we use sine, cosine. One thing I have to say, that whenever you are talking about tangent of alpha, it is also sine alpha divided by cosine alpha. You have to memorize this one also. Why? Because tangent alpha is equal to sine alpha is a divided by b. A divided by what? B. And cosine alpha, c divided by b. Now this b with this b is cancelled. A divided by c. The remaining is a divided by c is tangent. So we can say that tangent is sine alpha divided by cosine alpha. Also, cotangent alpha, it is cos alpha or cosine alpha divided by sine alpha. It means if you know the definition for sine and cosine, you are able to find tangent, you are able to find cotangent, you are able to find secant, and you are able to find cosecant. So we focus on trigonometry, in trigonometry, on two ratios, mostly, maybe 95%. Those ratios are sine and cosine. I think you have got. Write it, please. One thing I have to say, the word sine is coming from which one? I think in Indian books it's written that there was a I think philosopher by name of Aryabhat. He was living maybe 500 before Christ. He used in a circle for a curd the word Jeva, Jaya, I think. Jaya or Jia. This one. Jaya or maybe Jiva. Yes. Jiva. He used for the curd the word Jeva or Jia. After later, this word, which is Jeva or Jia, it was taken to the Arabic countries and they named senos, which means curve. And later on, it was translated in Latin word. This word senos, like sine. The sine is a Latin word which is taken from the senos, and senos means curve, and first it was used by an Indian philosopher whose name is Aryabhat. I think he lived 500 before Christ. And there was, I think, an English professor whose name is Edmond. Yes, Edmond Ganter. Edmond Gunther. He used the abbreviated form for the sign like SIN. It means if you're talking about the ratio of the sign, you have to use SIN, this abbreviated form. Later on, much later, the word cosine and tangent, they came in mathematics, which cosine means the complement of the sine. Cosine means the complement of the what? Of the sine. What does it mean? It means, for example, we have a triangle, right angle triangle. This is 90 degree. This degree is 30. Now, what is the complement for 30? It's 60. 60. Why? The complement condition is that both angles, the summation should be 90 degree. If this one is 30, 60 is the complement for the 30. If this one is 10, this should be 80. Why? 80 plus 10, it's 90. If this one is 15, this one must be 25. Why? 15 plus 25, it is 90. And one thing you have to know, that the sine of 30 is equal with the cosine of 30 complement. What's the 30's complement? It's 60. So sine 30 is equal with the cosine 60. Am I right? Or for example, if you want to talk about 12, now what is the complement of the 12? The complement of the 12, it is 28. Why? 12 plus 28, this is 90. So what's the complement of the sine? It's cosine. So sine of 12 is equal to cosine of 28. Like this one. Tangent also. Tangent 12, what's the complement for tangent? It's cotangent. Cotangent of 28. For secant, what's the complement for the secant? It is cosecant or cosec of the 12. This CO, it means complement of the previous ratio. And the word cosine, which means the complement of the sine, it was used for the first time in abbreviated form COS by an English professor whose name is Johann, I think, Mori. Johann Mori. He was the first man which used the abbreviated form of the cosine like COS. And one thing I have to say, that the word sine, cosine, tangent, whatever is, it is not in multiplication with the alpha. What do I mean? If I want to write sine alpha, it doesn't mean sine is multiplied with alpha. This is not correct. Sine of alpha, sine and alpha is not in multiplication. The word just sine without alpha, it doesn't have any meaning. Sine of alpha, what does it mean? Sine of alpha, it means sine of alpha. It means the ratio of the two sides of a what? Right angle triangle, the opposite with the hypotenuse. How much the opposite with the hypotenuse ratios are? It is 1 by 2, 1 by 3, 1 by 5, 2 by 3, whatever is. Sine with this one, also cosine with the angle, tangent with the angle, they are not in multiplication. These angles or with sine, and both of them gets a meaning, else sine is not defined. I think you have got. Write it please. The last thing that I have to say, for example, this is our right angle triangle. This is our right angle triangle. It is A, B, C, and this one is our alpha, acute angle. The triangle should be what? 90 degree. Now, if I want to define sine of alpha, what is sine alpha? It is BC opposite by hypotenuse AB. Now in here, I want to length these sides. Now we have here, is it A, the name of this one? It is, for example, what? DE. Now ADE, is this one a right angle triangle? Yes. Now how you can define sine alpha? This one is DE by what? AD. Now the question is, are they same or different? The answer is, you have to go to the early class. In geometry, we have defined the same triangles. Now ABC, is this one same with the ADE or not? ABC, ADE, are they same or not? Yes. Why? Because two angles, which is 90-90, and alpha is same in both of them. For this result, we can say that they are similar triangles. If they are similar triangles, so the ratio of this one, DE divided by AD and BC divided by AB, they are same. So both of them are same and equal. They are equal. Maybe this one is 3 and this one is, for example, 5. This one is maybe 6 and this one is maybe 10. So 3 by 5, it is equal with the 6 by 10. Why? You can cancel here. 3, both of them are divided by 2, 5. 3, 5, 3, 5. What does it mean? If the length of the triangle, a triangle, is lengthened, on that occasion there is no change or no vary in the what? In the value of the ratios of the trigonometric ratio. If the length of the what? Of the trigonometry change, if the length of the triangles, if the length of the triangles side or what? Or maybe lengthened or preceded in the same direction, are preceded in the same direction, in the same direction, there is no change in ratios of the triangle and of the trigonometric trigonometric ratios. There is no change. There is no change in the sine, cosine, whatever sine was. Sine was, for example, 3 divided by 5, and here it's also 3 divided by 5 if it is proceeded in the same direction. Now we have another triangle, which is a right angle, A, B, G, O, and H. Now AGH, this side divided by AG, it is the same which it was in ABC and ADE, whatever. The same is with the cosine, with the tangent, cotangent, and other trigonometric ratios. I think you have got. Write it, please. By the way, my lovely friends, support me on YouTube channel, please. It was our first lecture on the trigonometry. Inshallah, in upcoming lectures, we will have our best examples, our best definitions, and I will collect all the most difficult questions from the books, and we will have our solutions together, inshallah. By the way, love you all. Allah Hafiz.